Everybody, this is Mrs. Dinkelman, and I just wanted to make a video to go over this free response that we're practicing on Monday, November 9th. So on this one, they give us the equation, and they actually tell us what the answer is, so they want us to just verify that that is correct, and they just want to see our method. So we're going to have to do product rule a couple times with these. So I'm going to consider the 2x as one, and the 4x squared will be together as we're deciding first versus second. So I would go first times the derivative of the second plus second times the derivative of the first. And then be careful about that minus sign right here because we're going to have to distribute it. So again, first times the derivative of the second plus second times the derivative of the first. And then on the right-hand side, we get 0. We're okay skipping some algebra steps in here, so I am going to just gather the dy's here. So this is going to be 4xy dy, and let's see, that's going to be a minus 4x squared dy, and I'll move the dx's over. I'm going to start with this one because he's negative on this side. That means he'll be positive on this side, and then minus 2xy squared. Oops, that's a dx. So we would want to factor those out and find our dy dx. I'm going to just skip a little bit here. So we know these dx's over here are going to stay. Again, write as many steps as you need to, but if you want to skip, you certainly are welcome to. All right, and it looks like we want to divide here just to verify we have the same thing. So if I divide everything by a 2, I have something extra in there that I shouldn't have. So this is a really good time. So I'm looking here. I have a 4xy squared over, let's see, that would be a 2xy minus 2x squared. So I don't quite have what they have, which means I have a mistake, and you might have seen it earlier, and I saw it when I looked back here a second ago. This 2x right here, it really should just be a 2 because the derivative of 2x would be 2. And so I got to fix all those. So I kind of like in this problem how I get to do that. So that's just a 2y squared right here. Some more erasing. And go back here. Okay, so now what I like to do at this point is just kind of put a check mark like yes. Now remember, if all the signs are different, you're still okay, and you can kind of put a check mark. Okay, B says, find all the points on the curve whose y-coordinate is 2 and write an equation for the tangent line at each of those points. So what we're going to have to do, because y-coordinates mean we're talking about the original equation, we're going to have to plug a 2 back into that original equation. So I'll kind of have to go, maybe I can make it work. So first of all, 2x times 2 squared 4x squared times 2 equals negative 16. Again, I'm just grabbing that from that original equation up there. I forget that it's a little bit different than OneNote. Okay, so on here then, as we continue, we're going to have 8x squared. Nope, that's 8x. All kinds of interesting things I'm doing today. 8x minus 8x squared equals negative 16, so we just need to solve this. I'm going to move the 8x squared minus 8x over here, and let's see, factor out the 8. Okay, so we get x equals negative, or positive 2 and negative 1. So at that point, I would kind of do a couple things for myself. I would say, okay, I have this point 2 comma 2, and then I also have this point that's negative 1 comma 2. And so we have the point, but we need the slope. So to find the slope, we're going to have to find the derivative at each of these points. So we're going to look back up at what they have. So I'm just going to use this one since it's easy enough to see. So 4 times 2 times 2 is going to be 16 minus 4. And then that's going to be 8 minus 8. So this one is undefined, which means we have a vertical tangent line. That's going to be like an x equals. So what is the x coordinate? Well, it's 2. So x equals 2 is that tangent line. Okay, so for this next one, I'm going to switch colors so we don't get mixed up. So we're going to have 4 times negative 1 times 2, so negative 8, minus y squared, so minus 4. And then let's see, 2 times negative 1 times 2, so negative 4. And then that's going to be minus 2. So negative 12 over negative 6, which is 2. So that's our slope. So we have y equals slope, x minus the x coordinate plus the y coordinate. And it doesn't really matter what kind of format we have for that tangent line. Okay, so if we have a tangent line that's horizontal, what we're really saying is that we want the derivative to be 0. Remember, if it was vertical, it would be the reverse, so our tangent line would be undefined, so that would mean that there would be like a 0 in the denominator. So let me just write that note. Vertical dy dx equals undefined, and the way we get that is by getting a number over 0. So this one's the reverse. We're talking about 0 over a number. Okay, so let me go back up. All I'm really worried about then is setting the numerator of this thing equal to 0. So this 4xy minus y squared needs to equal 0. So we want 4xy minus y squared to equal 0. So I can see that everything has a y there. So we're going to get y equals 0. Oops, that should be a minus in between. Or y equals 4x. So what we're going to do is we're going to look back at this original, and I'm going to see if I can bring him down. So let's see if I can copy him. Maybe it will let me. I don't know if it's going to let me. So 2xy squared and then minus 4x squared y. Negative 16. Okay, so if I try to plug the 0 in here, what's going to happen is we're going to end up with 0 minus 0 equals negative 16. Well, that's clearly not a correct mathematical statement, so that's an extraneous solution. But what we're going to go ahead and do is try to plug in the 4x in for the y here. Okay, so let's see here. This is going to be 32x cubed minus 16x cubed equals negative 16. So 16x cubed equals negative 16, and so x equals negative 1. Okay, so feel free to make any comments on your FRQ. Let me know if you have questions based on that, and yeah, good job practicing.